Hey, again, this is Betsy Scott with IBACOS. I'm the director of the Housing Innovation Alliance. Thanks for joining us today for our webinar, Plug and Play Ductwork, looking at delivering comfort in low-load homes. Tim Beggs and Andrew Porschke with IBACOS are going to be sharing their expertise in today's session. This webinar, certainly the work that we're doing is funded, and Tim will talk about this more later, through the Department of Energy's Building America program. So we want to thank them for their support on this project, and is being presented as a benefit of Alliance membership. The Alliance is our collaborative innovation community. We have 75 builder members, and our programming is really driven on a lot of the issues that you're facing in the field and the information that you need to be more quality and innovation focused. And thank you certainly to our sponsors who support our programming and make webinars like today's session possible. Again, our presenters are Tim Beggs. He is a program manager for innovation programs within IBACOS and has 20 years of experience in HVAC design. So certainly brings a lot of expertise to this project, and has been coordinating with Andrew Porschke and others on our team actually to conduct this work. And Andrew has been designing and implementing the data acquisition process to monitor performance of things like the plug and play ductwork that we're doing. So they're going to go back and forth a bit today and share their expertise with you. You have the opportunity during today's session to participate by asking questions or making comments whenever you have them. Just use the little question function on your screen to type it in. I'll be monitoring those throughout the session. And then we've actually set a couple of specific times apart to do Q&A. But if you send us something and it feels like it's part of that discussion, I'll interrupt the guys as we're in session to get those questions answered so that everything makes the most sense to you as possible. But looking forward to getting, as I said, feedback or comments from you or questions that you have during the session today. And then we will also post an archive of this session if there are others on your team that you want to share it with, and a PDF of the slides later, and we'll send you a link to those as well. So I'm going to turn the floor over to Tim and Andrew.
All right, thank you, Betsy. We'll get started with some introduction and background to our topic today. So for over 20 years, IBACOS has been a leading partner and participant in the U.S. Department of Energy's Building America program. It focuses on research for residential energy efficiency and quality living environments. In existence 25 years now, IBACOS develops and utilizes methods to identify and disseminate solutions for better homes. Among these are the innovation pathway for bringing products to market and collaborative industry networks such as the Housing Innovation Alliance. IBACOS brings an understanding of builder and manufacturer needs and changing market landscapes while building relationships based upon trust and a shared passion for innovation. Andrew and I will be sharing time today, and here he is.
Thanks, Tim. Yeah, so a little bit of a recap on some of the past research we've done in the field of air delivery. So we've done different studies looking at things such as compact air distribution systems, bringing the ductwork into conditioned space, shortening your duct runs. We've looked at strategies such as a single point of air delivery, and along with that, then utilizing transfer grills with and without fans to try to find more simplified ways of delivering air and conditioning the spaces. We've done work with mini split heat pumps, and then more recently, we've been looking at smaller diameter duct systems. In the last year or two, we've worked on a project with the Department of Energy to understand this small diameter kind of rigid duct system with a manifold, and we are now going to present kind of where that research is leading.
Okay, well, here is the premise of our plug-and-play duct system concept in a nutshell, and we'll get into more of the details shortly. So the plug-and-play system is an air distribution system. It's under development with assistance from the Department of Energy funding, and we think it will be revolutionary to homes in the near future, and it has several distinct characteristics. It's a manifold arrangement of small diameter ducts where each duct run-out is a home run, meaning that there's a dedicated path to each space from the supply air plenum at the air handling unit. It's intended to initially utilize off-the-shelf products as a kit of parts to install a simplified duct system with less error, less waste than conventional duct systems. And those would be such as larger diameter sheet metal systems, flex duct, and even ductboard. Conventionally skilled tradespersons and home designers, they'll have a quick, efficient, and credible method for designing the air delivery system that provides reliable results in design and responds to the unique qualities that lower load homes have and that the emergency lower capacity comfort systems have. And examples of those are ducted mini split systems, small capacity central furnaces, and also heat pumps. That predictable performance for delivering thermal comfort is part of the impact that this system approach will have, because it will respond better to low load homes by delivering lesser airflows on a more consistent basis with less on and off cycling from the equipment. Due to the size of the system components and the limited number of different parts and pieces that would be used, the system is more easily gathered, transported, and installed. Overall, we believe that this system will be higher performing with better occupant comfort. It'll be easier to lay out, integrate, and install, and it will have a lower cost than conventional air distribution systems. We see benefits for builders, trades, and homeowners. But why is there an opportunity for this? What is the developing need? So we can talk a little bit about the business case and the why behind the scenes here. So conventional ductwork tends to bring a host of conventional performance issues with residential systems. The ducts tend to leak, and additional steps are required to provide sealing, and all that is not often done completely or adequately, and at times other trades will come along and undo a very good installation just to gain access to something else that the duct is blocking during the construction process. Due to their size and issues with installer access in tighter spaces, ducts are often installed in spaces that won't be heated or cooled, resulting in lower system efficiency, especially if those ducts are outside the thermal envelope and are leaking air as well. And also because of their size and the effort required to install the conventional ducts, they're not often well integrated into the home and may require unsightly bulkheads or soffits, fur downs, or drop ceilings to conceal the ducts. This can exacerbate another characteristics that these ducts tend to have, which is having segments that are inaccessible for maintenance, for cleaning, or for adjustment, and that's especially unfortunate when what should act as a seasonal adjustment damper or balancing damper is hidden behind a concealed surface. Due to the air velocities in the physical configuration, conventional ductwork tends to collect dirt, dust, and debris. And ducts are often a challenge for installers to simply design and install properly, and that may be due to the limited availability of skilled labor, something that we are all likely to be facing more often. And for example, design practices may not be followed for the deadhead of an extended plenum. That would be the photo on the lower right. And that's the distance between a duct takeoff and the end of the duct main. And that impacts the quality of the airflow and the predictability of the airflow. And of course, flex duct, and we have an image of that, it's often susceptible to a whole myriad of installation issues that increase pressure drop, restrict airflows, and end up decreasing system performance. But let's ask, what are some other driving issues for the plug-and-play system besides common quality issues that we see in the field? Well, there's an increased presence in the marketplace of homes that are referred to as high-performance homes, and these especially are homes that have a high level of energy efficient features. These are homes that have peak loads of less than, say, 1.5 tons of cooling or 25,000 BTU per hour for heating. You know, another threshold that IBACOS uses to define a low load home is anything with a load below 10 BTU per hour per square foot of livable area, or equivalently that would have an area per ton of about 1,200 square feet per ton. You know, we're often seeing total house airflows of 600 CFM, sometimes 400 to 300 CFM or even less for the entire house. When a home is designed in an energy responsive way with lower heating and cooling loads, conventional duct sizing practices may still be applied, making the ducts oversized for the peak loads, and may be then, therefore, even more oversized for the loads that are encountered on a typical day. It's a rather general statement to say that the residential HVAC market is facing challenges right now, bringing effective and efficient small capacity comfort system solutions to market for low load homes. A segment of that problem relates to the lack of design to optimally deliver heating and cooling to each space from smaller capacity equipment. Traditional duct systems, as I said, they're oversized and they have a lot of quality issues that I mentioned. In addition, conventional registers are used, and they don't often provide the throw or mixing necessary to address all of the load in the house or have the ability to condition all of the air volume in the home. And when that happens, comfort issues can arise in the low load homes. And research being done by IBACOS and others is showing that there are homes being built with the promise of high performance that can fall short of delivering on that promise, especially in the area of thermal comfort. And the term high performance then comes to question. Issues like these can represent a barrier to greater adoption or acceptance of low load homes, and such barriers should not be left to stand. The plug and play is one approach that helps, that aims to negate these problems. If you've seen any of the Department of Energy Building America research to market roadmaps, such as the one I'm showing here, you know that DOE has put a great deal of thought into where their present industry research may lead, and also about what research and industry collaboration steps are needed in order to reach what are felt to be important residential system performance goals. The goals for these roadmaps include developing solutions that become standard practice in the industry, managing risks to minimize problems of adopting new technologies or approaches, addressing solutions that yield optimal performance and cost effectiveness, and to recognize that solutions must be practical and profitable with a manageable degree of risk for builders and home improvement contractors that may adopt them. So some points of clarity for the audience for what we're seeing here. The blue bubbles in this diagram are research and development goals. The green bubbles are market engagement goals. Orange relates to codes and standard goals. Solid outlines are activities that are led by DOE, and dashed outlines are envisioned to be activities that are led by industry. The plug-and-play system fits into the DOE roadmap under the bubble outline in red on the top, and that's the ones for developing design procedures and tools for low-load homes. It presents as DOE initiative research and development. The point for showing the roadmaps here is to show that there is momentum or criteria coming from different segments of the industry that are helping lend support for the plug-and-play approach. And among those is a home for the concept within a greater DOE vision for residential performance. So how are we going about this development of the system? You know, the demand and the level of interest for a plug-and-play air delivery system was first gauged through various meetings and presentations and interactive inquiries, some technical committee work, and collaborations with members of the Housing Innovation Alliance. And we met with various industry stakeholders who could be impacted by a product or system development like this. So we set our sights on some basic objectives, and that would be to develop a simplified air distribution system for homes that accomplishes several things. It would solve the air distribution issues that I mentioned. It would deliver predictable performance, and then that would be in the areas of airflow, pressure drop for the system, comfort, and of course energy use. It's equivalent to an engineered design through a simplified method. It's easily integrated into a home and reduces installation time at the job site. And it's installed with less error and less waste. And we gave thought to how we could speed up the acceptance of this system beyond simply meeting our project objectives. We recognize that the plug-and-play system could revolutionize air distribution systems in a way similar to the way that manifolded cross-linked polyethylene, or PEX, piping has impacted plumbing distribution in the residential marketplace. PEX has lowered installation cost. It's 25 to 45% savings as compared to copper, depending upon the market. And this has helped grow the PEX market share in homes from 0% back in 1993 to 70% 20 years later. So with this duct approach that we're discussing, we'll have small diameter home run systems, we'll have modular plug-and-play components, and we'll have standard installation practices. We also have a great potential for installed cost savings with performance benefits. The residential ductwork market is on the order today of about $1.2 billion annually. And within the new construction market, with a target cost savings of 20%, we're seeking a 10% new construction market share within 5 years and 25% penetration within 10 years. This technology will largely, but not exclusively, ride the coattails of low-load home markets. And we also anticipate some utilization of this approach within the home retrofit market. So we developed a task outline for our project to manage the details of the 6 primary tasks that we found would be relevant to meeting our project objectives. And those are, I'll just read the list, it's the market engagement, lab testing, cost analysis, performance simulations, field data collection, and design methodology. We also considered how those task relationships would interact, and we found that how they're largely going to be and are being reciprocal and interdependent. And the result of that is very little of our work is actually progressing in a linear fashion. For example, every task that I outlined is actually feeding information to the development of a design methodology, and that's in task 6. And that methodology is one that can be used by a designer and installer to have a simplified method to design and install the system. I'll point out for clarity that our thermal comfort rating metric assessment is also a task in our project. That's task 7. But as we have presented that topic in the past through Alliance activities, we won't be addressing that today.
And before you go further into that, for those who are on the phone and haven't heard about the thermal comfort rating metric, at a 30,000-foot level, the intent there is to create a system for benchmarking, quantifying, and validating thermal comfort performance in a similar way to the HERS rating system. And we do have an archive of the webinar that we did on that that's available. When we send you the follow-up materials for this session, I'll send you a link to that archive as well in case it's something of interest to you. That's just it.
Great. Thank you, Betsy. Well, IBACOS, let's talk about some of our tasks. IBACOS worked with the Alliance to develop and conduct information gathering activities related to builders in 2 areas. And that would be annual benchmarking of the performance of housing that those builders build against key performance indicators related to high-performance houses. The cost of quality, including warranty and callback costs, was also there. This data will help determine the scope of the market opportunity for plug-and-play duct systems, and will determine what builders and what regions would be most receptive to rapid adoption of the technology. We work with the Alliance to conduct information gathering activities focused on consumer attitudes and actions as well, and those were related to the comfort and other key performance indicators for high-performance homes. So in a nutshell, consumers, we found, want cost-effective products and solutions that greatly reduce energy use, but also improve building comfort. As part of our market engagement tasks, we also have introduced our concepts and our goals through other industry groups such as ASHRAE and the Pennsylvania Housing Research Center. We've received valuable feedback from various audiences, including making contact with likely stakeholders and possible collaboration partners on both the builder side of the industry, and they would help us demonstrate the system once it's ready. But we've also interacted and received good feedback from manufacturers that we are looking to develop partnership with to continue into a product development phase.
Great. So to jump into some of the tasks that we're accomplishing here, we'll start with the lab testing phase. So the goal of this phase is to really characterize the performance of different duct materials, duct and configurations, so that we can fully understand the airflow and pressure relationship for some of these different small diameter duct materials. Something else that we're trying to characterize is the temperature drop along the length of the ductwork. And then also looking at different duct materials beyond PVC. And the goal of this testing is really to feed data into some of those other tasks. We're feeding data into the simulation. We're feeding data into the design methodology and using this as a basis for that design methodology so that we can really predict the airflow that would be coming out of each duct run. So to look at a little bit of data here, we're starting with the pressure drop versus airflow relationship. And this is kind of the relationship where the different materials and the diameters really live or die. And where the goal is to minimize the pressure drop per length of ductwork. The easiest way to do that is obviously to use larger diameter ductwork. But we're limited in the fact that we're trying to contain the ductwork within interior walls and different cavities within the house. So we're driven toward the smaller diameter. But what you can see here is that jumping from a 2-inch PVC pipe down to a 2.5-inch PVC pipe, we're almost halving the pressure drop per foot. So a small change here has a very profound impact. Looking at different duct materials, PVC versus a smooth steel conduit, we see very similar performance for the same diameter. So the goal here is a very smooth, smaller diameter duct material. So something else we're doing is testing different elbow configurations. The graph that you see here is simply showing 4 different tests for the same elbow. We're trying to verify that our results are reproducible. And then based on these measurements, we can understand that flow relationship. One thing that we've been able to do is create an equivalent length measurement, which could potentially be used in the design methodology. And then finally, one of the things we've been testing is the temperature drop along the length of the ductwork. Something we found whenever we installed PVC up at our lab house, and we'll get into some more of these details a little bit later, but whenever we first installed the duct system, we saw kind of a higher than expected temperature drop along its length. The thought process being it's installed within conditioned space, that we wouldn't have a significant temperature drop in uninsulated ductwork. However, that wasn't the case. And so we've done some testing. Here are some different materials that don't have any insulation on them. We're looking at a flexible type of ductwork, PVC, that steel conduit, and a typical snap lock type of ductwork. And then, so we tested it without insulation and with insulation. We added just a simple R6 type of fiberglass batt wrap. And doing that alone, we were actually able to increase the insulation value by roughly an order of magnitude of 4 relative to the base case of an uninsulated duct system.
So I'll add that we have done those evaluations at a variety of temperature, the supply air temperatures going into the test rig. So we showed data for 45 degrees Celsius, which is about 113 degrees Fahrenheit, but we've also done tests at upwards of 125 degrees Fahrenheit and also down at 100 degrees Fahrenheit to sort of capture the range of what would be expected supply air temperatures coming off of a variety of different system types that would be feeding into the distribution system. Another task we have is our third task, which is to evaluate and do an analysis on the cost associated with this type of approach. And primarily here we are intending to assess the value from actual monitored contractor installations. So I'll speak to the nonlinearity of our process. What we first need in order to complete this task is a real strong working design methodology that we are able to then give to a contractor and have them follow the procedure that we've outlined, follow the instructions that we'll be writing for that procedure, and then designing and installing a system based upon that. And then within the same effort to design and install more conventional systems, sheet metal, flex for example, in this same mock-up house that we have in our laboratory, and do comparisons about how much time and effort it takes for the contractor to install the systems. So we call those time and motion studies. It makes up one component of cost. This wouldn't be the material cost, but it would be all the aspects of installation, and it would include procuring the material all the way up through the actual installation and even testing in the home. So the primary work that we've done so far is basically to build a shell, a framed shell of a townhouse that we've actually had some experience with one of our Colorado builder friends.